Okay, and we're back. Okay, now that we have a window, we need to create a bitmap so we can draw it. The other way, it can't just be any bitmap because you're on Windows. We have to create a bitmap that we can write to directly because uh, Windows doesn't allow you to do a write directly to the screen. So you have to write directly to a memory and then transfer the memory into the window, which transfer to the screen. So you have to create a special program, a special structure called a DIB section. Okay, I've been reading up on this. It's called a create DIB section. So let's create an object for encapsulate. Otherwise, it's just going to be too complicated. So we create the object just the same way we did with the window. We have to encapsulate everything so that we don't have to start over every time. Okay, type def structure. Okay, give it a name. Type, is it type bitmap or yeah? Type window bitmap. We have to be clear on what we call things. Otherwise, we might get confused. Okay, what do we need? Okay, just like Windows has a handle. Okay, h bitmap or handle h bitmap handle. Of course, it needs a width. Is it double word on double word? Bitmap width, not bitmap width. Double word bitmap width. Bitmap height. Okay, well, of course we need to write directly into the screen. So void or p void. A void pointer. Void pointer bitmap data. Okay, so we need to be able to first write directly into the memory and then transfer all that memory into the window. That's what all this for. Okay, so first we have to create the bitmap, and that can get complicated. Type window bitmap create. The names are long, but this is just to make sure that we are very, very clear on what is what. We don't want to get confused here. There's going to be a lot of objects, so we have to be clear on what everything means. Unsigned long width, unsigned long height. Okay, I don't think we need anything else. Okay, now we need to figure out how to create the bitmap. Create DIB section. Why do you need to create a DIB section? Okay, first we start with the bitmap info. BM info. Not M4. Okay. Okay, BMP bitmap info. Bitmap info. Okay. Step 1. Initialize the bitmap info. What is a bitmap info? We're gonna have to keep looking at everything. Bitmap info as a bitmap info header. Okay, bitmap info, BMP info, info dot what is it called again? BMI header. Okay, BMI header. Dot BMI header dot. Oh, sorry. Okay, I have to be clear on what everything means here, because we have to set all the objects to the right values. Okay, let's copy and paste, just so we know what. Oh shoot, we copy way too much. Okay, bmf4.pi size equals what? That size equals size of. It doesn't really say. Oh, size is the size of bitmap header. Okay, size of. A good thing to note is that we have to keep looking at everything just to make sure we know what means what. Size of the entire structure. Is the structure just the header or Yeah, I'm pretty sure it's just the whole thing. Yeah, it's the whole thing. Okay, BI width. I'm pretty sure I've done this before, so I should know how it works. BI width equals width. Dash. Okay, width. Okay, this is something I've made a mistake on several times before, so I know this one. The height. You can't just set the height to the right height because you have equals. You have to set it to the negative height. I don't know. I have no idea why they do that, but that's just something that Windows requires. That you have to set it the height to negative. The bitmap needs to be upside down. Again, I have no idea why they do that. Okay, long height. Okay, number of planes. Okay, the good news is when we're done with this, we never have to think about this ever again. So, number of planes, I think, yeah, I'm pretty sure it's one. I don't even know what the plane is, but number of planes in a minute. The value must be set to one. That's what it says here. BI count. Okay, so BI count. What is BI count? Okay, BI count. Number of bits per pixel. Yeah, 32-bit. We're gonna use 32-bit. We just set it to default 32-bit because I don't want to have to worry about anything else. Okay, BI compression. It should be uncompressed, right? BI compression. Uncompressed. Okay, BI RGB. That's the one. BI RGB. Again, it's good that we only have to do this once because otherwise this would get very tedious very quickly. BI size of image. Okay, what size image? The image must be set to 0. Okay, size image set must be set to 0. Simple enough. Okay, okay, a lot of this stuff means nothing to me. Whatever. Must be set to 0. Yeah, I don't have to worry about all this stuff. Colors used. Yeah, I'm pretty sure all this stuff can be set to 0. Well, just to be clear, I just set everything to 0 because I don't think it's that important. Okay, set to 0. I've been reading up on this stuff. Okay, just set 0 memory. Memory. 0 memory. And BMP M4. BMP M4. And how big should it be? Size of bitmap M4. Okay. Okay, we have everything here. Size of bitmap M4. Okay, good. Everything is set to 0. Okay. Now for the really hard part. We have to call the create DIB section function. Okay, what is involved here? H bitmap handle. Handle equal create DIB section in whatever HDC. Do we need a DC? Done this before. I don't think a DC is really necessary. It's going to be necessary in other functions. Bitmap M4. Okay, const bitmap M4 and BMM4. Okay, same thing. And BMP M4. So we need to point to the structure we just initialized, assuming everything's been initialized correctly. Usage. What is usage? Usage. The type containing DMP PAL colors or DMP RGB colors? PAL colors is yeah, whatever. It's a RGB colors. Okay, and usage is RGB colors. Okay, this can get really complicated. Oh, and this part right here. Bits. I pointed to a variable to receive the bits. It's a pointer to a pointer. Okay, void pointer. Oh, what am I doing? Void pointer bits. Bits. Oh, why does it keep saying that? So potential fixes. Like I said, oh. Visual Studio can get very annoying sometimes. Okay, if I don't do that, it just complains. Okay, it's a pointer to a pointer, bits. Okay, this is necessary right here. So, okay, so bits. Handle. What handle? Okay, wait, I have to check this. Handle. File mapping. Yeah, to type that can be null. Okay, null. Handle, its section is null. Okay, offset. Offset is what? The offset for the beginning of the file mapping. Yeah, we don't use that. Null. Okay, null. Okay, this should work. Okay, if handle equals 0, we have to check if the handle is right. If handle equals 0, oh no, if handle not equals 0, because we need to make sure that we set everything, we set parent to the correct values. Okay, parent. Okay, Bitmap handle equal handle. Parent. Bitmap width equal width. Parent. Bitmap height equal height. And parent bitmap data equal bits. Okay. Otherwise, we set everything to 0. Okay. Return 0. Okay, what else? Return 1. That's a lot of stuff. Okay, so I think we're done creating this thing. But now comes the hard part. Bitblit. We have to show, okay, bitblit. Okay, bitblit function. Okay, so is there an example that show me how do you do it, right? Because this can get really complicated real quick. Okay, HDC mem bitblip, HDC mem, HDC window. So SRC copy, bitmap show long, type window, bitmap show. Show what? Okay, and type window bitmap pointer parent. Type window target. Or just window. And long X, long Y. We need to know where in the window we should show it, because it's not exactly okay. Now for bitblit. Okay, first of all, we need to do a memory DC. HDC mem. No, HDC mem. HDC mem. Memory. We have a regular DC and a memory DC. Okay. HDC. What is HDC? HDC is the handle to a device to a destination device context. Okay, so that's the one from the window. I have to check this again. Let me go check this. Okay, HDC is the device context of the window that we're writing to. Get DC. Get DC window dot window handle. Okay, we have the DC for the window handle. HDC, what am I doing? HDC equals. Okay, HDC mem equals. Okay, this one's more complicated. Create compatible DC. Okay, out of what? I have to check again. Yeah, I'm back. Check HDC create compatible DC out of HDC. IDC that is similar. Okay, we need both of them. Okay, bitblit. What does bitblit do? HDC. Okay, that's the destination. Bitblit is the destination, I think. Handle to a device content. What am I doing? Where am I? Oh, why am I here? Okay, bitblit is the destination. Destination device context. Okay, X, Y. Up the upper destination rectangle. Okay, X, Y is the destination. Okay, X and Y. X and Y. That's the destination. Client width and height. Okay, what is that? CX. The width of the destination rectangle. So it should be the same as the bitmap rectangle, right? Yeah. Bitmap. Bitmap dot bitmap width. Okay, bitmap dot bitmap height. Okay, what else? That's the destination. HDC mem. That's the destination device context. And what else is there? Upper left of the source rectangle. Okay, I got this right here. Upper left of the source rectangle. What am I doing? Upper left of the source rectangle. Okay, there it is. Upper left of the source rectangle. Okay. Okay, bitmap. Oh, parent. What am I doing? Parent. I'm playing myself here. Okay, HGC mem, source rectangle 0. Everything 0 again. What else? SRC copy. Oh, SRC copy. That's the same thing. I got it. SRC copy. Okay, that should do it. Okay, when creating a DC, we have to release the DC immediately after. Release DC. If we don't release it, it might cause problems. So we have to keep everything clean. Release DC. Okay, which DC are we releasing? Release DC. Window DC. Windows handle. HDC. Okay. We have to release the DC of the window handle, and then we have to destroy the other DC. Delete object. We have to delete the DC we've created. HDC mem. Okay, so I think we're done. Return 1. Okay, type window bitmap show. Okay, last function. Type window bitmap destroy. Okay, parent. I think we forgot a few things, but we have to clean that up later. Okay. Oh yeah. Let's copy from this. We have to keep everything clean, otherwise we risk making a lot of mistakes. These things can get very complicated very quickly, so the important thing is to make sure that everything's kept very simple. Okay, window equals 0, Okay. If mine equals 0, okay. We need to destroy the window. How do we destroy a window? Not a window, just a bitmap. Delete object, that should do. Delete object, bitmap, dot bitmap handle. Oh no, parent. What am I doing? Parent.bitmap handle. Okay. And as always, we have to keep everything. We created something and we have to destroy it to avoid memory leaks. That way you keep everything simple and clean enough. Okay, set everything to 0 and then return 1. Okay, let's hope everything works. Okay. So type window create. Type window bitmap create. Okay, and bitmap. Okay, let's set it to 100. 100 times 100. That should do. No, and bitmap. Oh, what am I doing? Wait, did I erase this? Type window, type bitmap. You know what? Type window bitmap is just too long. If we're going to simplify everything, just call it type bitmap. We're not likely to get confused about that. Just call it type bitmap. There's no need to go all the way. Type bitmap. That's a short enough name. Type bitmap. Bitmap. Okay, we're good. Okay, type bitmap create 100 times 100, and then type bitmap show. Okay, type bitmap show. Okay, and bitmap, no, and bitmap, not bitmap, and window. Okay, type bitmap destroy. Type bitmap destroy and bitmap. Oh, we have to show 10. Okay, let's just make sure we didn't miss anything. Build solution. Did we miss anything? Oh, we made quite a few mistakes. Okay, first mistake is we put this up here instead of down here. Let's try this again. Everything works. Okay, let's run. And it doesn't work. Yeah, it didn't work this time because I forgot another function. Yeah, turns out we forgot another function here, right here. Yeah. It's not enough to create the disease, we have to select the object. Yeah, that's what happens when you do everything live. Select object. select object mem hdc mem, no, select object hdc mem or we have to select the bitmap into the, we have to select the bitmap into parent dot bitmap handle. Yeah, there's no point being bleeding if you don't know what you're bleeding, and that's why it doesn't work. Okay, let's try this again. Hopefully this time it will work right. And maybe I should test the code. Oh, there it is. There it is, right here. That's our bitmap right here. Okay, it's a bit small, so let's make it larger, just so we can see it. 10 by 10, 100, let's see, 500 by 500. Let's try it again. We build. Okay, we build. Oh, there it is. 500 by 500, a little larger. Oh, let's try it again one more time, just to be clear. 1000 by 1000. Yes, we build. Yes, we're building. Oh, there it is. Okay, we're not drawing anything right now, but now that we clear that it works, I'm gonna have to clean things up and put the code into a file just to make sure everything's clear. But let's review everything. We have the create DIB section where we initialize everything, and then we create the DIB section. But none of that matters, because all we need is to notice the bitmap and then a bunch of function that operates on the bitmap. Let's just show the functions: create, show, and destroy. Later we're gonna have other functions for drawing on the screen, but we don't need those right now. Okay, so all we need to know is this part right here, hbitmap, and then functions that does stuff to bitmap, and then we can just call the bitmap functions, and then we have a bitmap, and that's it. At the next time.